Danny, you're doing it wrong.
No, you're doing it wrong, you silly dog.
Can't you clearly see that cosine squared x is equal to tangent squared x minus sine squared x?
What are you talking about? It's you who clearly doesn't see that that's wrong. Cosine squared x is equal to 1 minus sine squared x.
What? The math hurts my eyes.
Your wrong answers burn my eyes. God?
You dumb puppy. I've never seen a dog as dull as you.
Fine, since y'all can't stop arguing, my hands have been forced. Now you both will be stuck like this until you can work together and solve 3 trig identity proofs. If any of the proofs are incorrect, the curse will last forever.
Stuck how? Oh no, this can't be happening. I'm in your body.
This is weird.
I want myself back.
I think we should start on these trig identities. I want out of this mangy body as soon as possible.
Agreed. For our first trig proof, we have cosine x plus sine x times tangent x equals secant x. So we're going to split up the sides, and we're going to work on the left side. So cosine x plus sine x times tangent x becomes sine x over cosine x. I multiply cosine x times 1, which would be cosine x over cosine x, so that we can have a common denominator for each of the parts. And then sine x times sine x over cosine x equals sine squared x over cosine x. That becomes cosine squared x over cosine x plus sine squared x over cosine x. Now that we have a common denominator, we can add both of the numerators. That turns into cosine squared x plus sine squared x over cosine x. Cosine squared x plus sine squared x equals 1, so we can cross that out. And that becomes 1 over cosine x, which is equal to secant x.
I'm getting better at this.
I'm surprised you did this first problem. You still have 2 more to do. Impress me.
So for our next problem, we are going to be doing cosine squared x equals to cosecant x times cosine x divided by tangent x plus cotangent x. So now we know what cosecant is, so we're going to simplify that cosecant into 1 over sine x times, and multiply that times cosine x over 1. We're going to divide all that by sine x over cosine x, which is equal to tangent x, so we're simplifying that to make it easier for us. We're going to add that with cosine x over sine x, which is the opposite, or the inverse of tangent x. Now we're going to simplify this more. We're going to simplify 1 over sine x times cosine over 1 into cosine x over sine x divided by sine x times sine x over cosine x times sine x. So what we're trying to do here is get a common denominator so we can factor out like numbers. We're going to add cosine x times cosine x over sine x times cosine x. So we're still getting the common denominator, trying to get a common factor in the denominator. So now we can factor. So it all becomes cosine x over sine x times cosine x sine x over sine squared x plus cosine squared x. We do that because the two fractions above had the same denominator, so we could simplify that. So now the problem becomes cosine x over sine x multiplied by cosine x sine x over 1. Now we can cancel out the sine x's, and we're left with cosine x over 1 times cosine x over 1, which is equal to cosine squared x. Now cosine squared x equal to cosine squared x. Some of this are starting to make sense.
Yeah, it is.
Okay, the third problem is cotangent x plus tan x equals secant x times cosecant x. So the first thing we're going to do is turn cotangent x into cosine x over sine x. And then tan x into sine x over cosine x. Then, to add, they need to have a common denominator. So we're going to multiply cosine over sine times cosine over cosine. And we're going to multiply sine over cosine times sine over sine. This will give us cosine squared x over sine x cosine x plus sine squared x over sine x cosine x. When we combine these, this will give us cosine squared x plus sine squared x over sine x cosine x. And cosine squared x plus sine squared x equals 1. So 1 over sine x cosine x. And we can separate that out into 1 over cosine x plus 1 over sine x, which equals secant x cosecant x. And that equals secant x cosecant x.
Wow, I can actually do this now.
And you didn't need any of my help.
You have completed all 3 problems? I must say, I'm impressed. Okay, you are both switched back now.